Hello, this is Mr. Best. Welcome to Chapter 6, homework questions 116 to 121. Question 116, find the slope and y-intercept for each line below. So we'll go ahead and start with question A here. We got 2x plus 7y is equal to 14. We want to solve for y. That's probably one of the easiest ways to find the slope and the y-intercept. So we'll isolate the y by subtracting the 2x first. And then we can divide everything through by 7. And then we have the equation y equals negative 2 sevenths x plus 2. So therefore we need to make sure we answer the question is what is the slope? The slope is negative 2 sevenths and the y-intercept is at 0, 2. B, we have y equals 6 minus x over 3. This is close to being put in slope-intercept form, or we could even consider it. But I'm going to rewrite it so the mx is first. There's a 1 in front of the x, so this is 1/3, actually negative 1/3 x. And then that's a positive 6, so that's just 6. That just helps actually see the slope as negative 1/3, and then the y-intercept is at 0, 6. C, y is equal to 10x minus 2, and all of that is divided by 2. So we could break that up into parts. We could say 10x divided by 2 and negative 2 divided by 2. So that'll help us see once again what the slope and the y-intercept is. Slope being the coefficient in front of x is 5, and the y-intercept is 0, negative 1. And the last one is written in slope-intercept form. You don't see the y-intercept because it's 0, so I just put a plus 0 so you could see it. And then your m is 3, and your y-intercept is at 0, 0, or the origin. Question 117. Solve for each x in the equation below. So once again, just continuing to work on being able to solve one-variable equations. A, you have 2x is equal to 8, so one step, divide by 2. X is equal to 4. B, 2x plus 2 is equal to 10, so if you subtract 2, you get 2x is equal to 8, which is the first problem. Divide by 2. X is equal to 4. Problem C, 6x plus 2 minus 4x is equal to 10. Combine your like terms. That's 2x plus 2 equals 10. Well, there's problem B. Subtract 2 to both sides. There's problem A. Divide by 2, and x is equal to 4. Hopefully you see a trend. D, 2 times the quantity 3x plus 1 minus 4x equals 10. Go ahead and distribute. 2 times 3x is 6x, 2 times 1 is 2. Now you have variables on the same side, so combine them. You get 2x plus 2 equals 10. Subtract 2. Once again, you see the same problems you saw previously, and x is equal to 4. So on part E, it says, check your solutions for the equations above. What do you notice? So you can see that all of the answers are at x equals 4. And so really all the equations are equivalent in terms of your solution being x equals 4. And if we plug in x equals 4 into all of those equations, then we'll get, like on the first one, we'll get 8 equals 8, and then all the other ones will get 10 equals 10, which means it is a solution. So once again, check your solutions. You would actually just plug those in. I'm not going to check every single one of them, but if you wanted to check the first one, it's 2 times 4 equals 8, so 8 is equal to 8. And then the next one would be 2 times 4 plus 2 equals 10, 8 plus 2 equals 10, or 10 is equal to 10. So we're checking each of them. They're all going to equal 4. And so they all have the same solutions. Question 118. Write 3 different single-term expressions that are equivalent to x raised to the negative 2. At least one expression should use division. Another should use multiplication. Show how you know that each expressions are equivalent. So we're going to do 3 different ones. Okay? So the problem itself is x raised to the negative 2. So what's another way that you could rewrite that? Well, one of the ways is we could actually simplify x to the negative 2, and we do that by using division or moving the x to the negative 2 to the denominator to make it a positive 2. So it should say, it says we should use division, so we did use division there. Number 2, how could we use multiplication? So when we multiply, what are we supposed to do with our exponents? If you forget, remember when you take x times 3x plus 1 and you distribute, x times 3x is 3x squared. So what did you do with the exponents? You added them. So what two numbers could you put here so that when you add, you get -2? So obviously there's a lot of variations that you could have, so you can just pick whatever you want. Let's do x raised to the 5th and x raised to the -7. So now when I add, I get x to the -2nd. And a third way, we could do something like x raised to a power and then raised to another power, which means on this one we'll be multiplying. So what two numbers could you use that would multiply to give you -2? Well, you could do x to the -1 and then raise that to the 2nd, and that would equal x to the -2. So there's a third way that you could possibly look at that as well. And there are other variations of this, so please don't think these are the only ones. There's lots of different ways. Even on number 1, if we wanted to use division to get -2, we could, ask ourselves x raised to a power and x raised to another power, and with that we subtract. So you could have, what two numbers subtract to give you -2? If you did, let's say, x to the -5th and x to the -3rd. And I guess I could also do it, maybe this would be better, x to the 3rd and x to the 5th. And so when you subtract, you get -2. But once again, lots of variations. Question 119. If g of x equals the square root of the quantity x minus 3, and then plus 1's on the outside, find the values below. If there is no solution, justify your conclusion. So on part A, it's g of 7. So what you're saying is, for every x value, you're going to replace it with 7. So this is equal to the square root of 7 minus 3. That's underneath the radical, and then plus 1. So order of operations, you have to do grouping symbols first. And so that's the square root of 4. Square root of 4 is 2. So this is equal to 3. So you should say g of 7 equals 3. Your input is 7. Your output is 3. On B, now you have g of 4. So once again, you're going to plug 4 in for x. And then simplify. 4 minus 3 is 1. The square root of 1 is 1. 1 times 1 is 1. So 1 plus 1 is 2. So g of 4 is equal to 2. C, we're doing g of 8. So we have the square root of 8 minus 3 plus 1. And that will give us the square root of 5 plus 1. And on this one, the square root of 5 is not a perfect square like it was with 4 and 1, so we're going to plug this into the calculator. It doesn't say what to round to, so we'll just round to maybe 2 places here. And so g of 5 is approximately 2.24. I went ahead and rounded to the nearest hundredths, plus 1. So g of 8, and usually when we write approximate, we use like a little curve thing here, 2 curved lines, and we get 3.24 approximately. And once again, that means it's approximate, it's not the exact solution or value. And then the last one is g of 2. So we plug 2 in, 2 minus 3 plus 1, and we get the square root of -1. And if you try to plug in the square root of -1 into your calculator, or you just think about it, what number times itself gives you -1? There's no possibility of that in the real number system. So with g of 2, there is no real solution for that. And so I just said no real solution for g of 2 because you cannot take the square root of a negative number, or at least not yet in terms of the real number system. And so that answers the 4 questions dealing with the square root function. Question 120, match each graph below with its domain. So graphs 1, 2, and 3, and you're matching up with A, B, and C from above. So domain, remember, as a reminder, domain, these are your x values. So when you're looking at the graph, this is a quadratic or a parabola U-shaped graph, but what happens to your x values? Well, this graph continues to go down, but it also continues to go left and right. So number 1, your domain is all real numbers. So that would be number 1 matches up with the domain of A, which is all real numbers. Graph number 2, your domain, once again, your x values. So it starts at 3 and only takes on values that are to the left of 3. So for that one, we would want C, which your domain is all values of x that are less than or equal to 3. And so process of elimination, but let's also look at it for number 3. Your domain keeps going to infinity that way, but you can see right here, it starts, or it's going to start at -2. And so it gets closer to that line but doesn't actually hit it. So that would be B, where your domain is all x values that are greater than -2. So question 120 is dealing with the domain of Question 121. Graph the rule y equals -x squared plus 4x and label its intercepts and vertex. So for right now, us graphing quadratics, -x squared plus 4x, we will learn a different way later on. But for right now, we're just going to use a t-chart. We're going to plug in some negative values, plug in some positives. And what we're looking for is the U shape that we know should exist. And so we're looking for that symmetry as well. So if we're not getting it, we need to make sure we go, I might need -2, -3, I might need 4, 5, whatever it is. So I'm just going to plug in some numbers and see where it gets us right now. So on your calculator, or you can do this all on paper, this is negative. Only the x is actually being squared, though. So you're only going to square the -1, not this on the outside, plus 4 times -1. So if you plug this in on your calculator, make sure you use in parentheses when you square that. So this would actually be negative, and then -1 squared is 1, and 4 times -1 is -1. So y would be -5. So that number fits nicely on the graph. And then we'll just do the next one. Y equals -0 squared plus 4 times 0, which in that case, everything's going to cancel, so it's going to give you 0. And then, as I said, you can use your calculator for this. I'm just kind of showing you what it would look like if you plugged all these values in. But this would be -1 plus 4, and that would be 3. So y is equal to -2 squared plus 4 times 2. So that would be -4 plus 8, because we're only squaring the +2 and then the negative follows. And so that's y equals 4. Maybe I can show you one more here. So y is equal to negative and then the quantity 3 squared plus 4 times 3. And so that'll be -9 plus 12, which is 3. So you now start to see there's this repeat value. So if I plug in 4, I should have symmetry, and that should be equal to 0 as well. And if I plug in 5, I should get the -5, because quadratics have that symmetry. So I'm going to go ahead and graph this. I have -1, -5. So there's that point. 0, 0, 1, 3, 2, 4, 3, 3, 4, 0. And because of the symmetry, I'm also going to put 5, -5 as well. And so we do want to graph it, so let's go ahead and make that line a curve there, nice smooth curve hopefully. And we've done the first part, we've graphed it. We also want to label its intercepts and vertex. So the vertex is the max or min point. In this case, it's the maximum point. So your vertex is at 2, 4. Your x-intercept, one of them is at 4, 0. Another x-intercept is at 0, 0. And this also represents your y-intercept. So now I've labeled them on the graph, but I'm going to go ahead and write them down here as well. So the x-intercepts are at 0, 0 and 4, 0. Write them as ordered pairs because they are points on the graph. The y-intercept shares with the x-intercept because it is at the origin at 0, 0. And then the vertex, that maximum point, is at 2, 4. So we have the graph, and we've labeled and identified the intercepts and the vertex.